right, so one last thing we're going to look at math-wise for this unit is whenever we are especially doing labs, whenever we're trying to analyze our data, we look at our error. So error is the difference between the accepted value and experimental value. The accepted value is the correct value based off of resources or the outcome we should have gotten through performing the lab. So say that we're doing a lab where we are measuring density. Remember, everything has a set density on our reference sheet. That is our accepted value. The experimental value is the value that you measured in lab. So based off of your data, what did you measure the density to be? And what we end up calculating is we're going to end up calculating percent error during labs and experiments. This looks at how far from that accepted value is our data. So to find percent error, and I'm going to rewrite this because it doesn't let me type it very nicely. So percent error is the absolute value of the accepted minus our experimental divided by the accepted value, and then times 100 to change it into a percent. So it looks at the difference between the two and what percentage of the accepted value is that number itself. This is a formula that is not on your reference sheet. So this is one that you will need to know for the test next week. But whenever we use this on labs, typically you will have access to look up this formula, or it will be given as part of the lab instructions. So let's look at an example of how this is going to be calculated. All right, so here's an example problem for percent error. It says the density of copper is 8.92 grams per cubic centimeter. It says in a lab, we determine the mass of copper sample to be 2.6 grams and the volume to be 21 milliliters. What is our percent error? And the reason that volume's in milliliters is a lot of times we will do water displacement to measure volume of something that's in a regular shape. Because remember, a milliliter and a cubic centimeter are the same thing. So here we're wanting to find percent error of that density. But what we measured in labs was, or in lab was the grams and volume. So we need to find density based off of our lab data. So with our lab data, we have the density is our mass is 2.6 grams divided by our volume, which is 21 milliliters or cubic centimeters. Remember, they're going to be the same unit. They're pretty synonymous. So if we were to divide those, we get our experimental value, which is 0.12 grams per cubic centimeter. And I left it at 2 sig figs since that was what was originally given. Now, that is based off of our data. So we may have measured something wrong, but you can't go back and change your data. So we would calculate our percent error using whatever value we have from our data. So it's possible that maybe our scale was not zeroed properly or something like that. But to find the percent error, we said we have to do the accepted value, which is the measured density of copper on your reference sheet. So that's the 8.92 minus the experimental value, the 0.12, divided by the accepted value, that 8.92 times 100 to make it a percentage. So I would suggest, because you are doing absolute value of the top, subtract them first, because sometimes you will end up with a negative number, but you need to make it positive. So if you subtract the top, it's 8.8. There we go. divided by 8.92 comes 100 to make a percentage. So then you can plug in the rest. And we get here that this is going to be about a 99% error. So that's really far off from what we should have gotten. So we probably did something wrong. Whether our scale was not zeroed, maybe we weren't reading our graduated cylinder correctly, something like that. But mistakes do happen. So don't get discouraged if you end up with a very large error, especially because we are not working in optimum lab conditions or in a controlled environment all the time. But that's how you are going to calculate percent error. Like I said, that formula is not on your reference sheet. So that is one that I would make sure that you remember for the upcoming test. But that will be used in labs throughout the course of the semester.